And the system integration is very important. First, the functional integration. Warships are composed of the three systems: platform and the special performance systems and the combat systems. Platform is HME, hull and propellant electric systems. And the special performance is the survivability, stealth, and noise and vibration, shock and EMX. Combat systems, weapons and sensors and the system interface and many electric systems. So all the functional items cross some functions and the system integrated and the compromise best. And the performance integration is needed. As you see, the power, speed, resistance, response, support, they closely interfaced and they oppositely interfaced. The propellant plate, for example, this plate is related, and the propellant plate is stack length is related like that. All its performance are optimized to maximize its function. Design spiral. As you see, the many naval architects can see it like this design spiral. First is the concept design. Baseline 1 is concept design, and baseline 2 is the basic design. Baseline 3 is the detailed design. So as you see, the owner requirement and payload and hull form and speed and arrangement and weight estimation and stability, speed, power, like that. From the concept to the details and converge for performance of the warships. And I'd like to explain about the external design spirals. This is the internally compromised and converge the performance in the naval ship design, but externally also very related and consider the externally design spiral for some difference. For example, the human systems and survivability and the design, things like that, or all the externally consider the design spiral. And the information data integration is, we call the networking is important. In these days, open architecture strategy is applied, and shipboard enterprise network, and all the Navy increased the ability to use the standardization software and the commercial off-the-shelf cuts to repair easily. This is the Jumart destroyer in the United States. So bridge and deck house and all engine room and all the systems are networked simultaneously. And combat system is very, very difficult and very complicated. As I before said, this is some destroyer. There are many warfare areas. First, anti-air warfare. This is the anti-warfare. So this ship carry out the warfare with anti-air aircraft and missiles, drones like that, and underwater warfare and surface warfare. 3 groups. So for the underwater warfare, so noise maker and hull-mounted sonar and torpedo and towed array sonar and anti-submarine attack. This is the related that, and surface-to warfare for that, gun, anti-submarine warfare, and the missiles and the anti-air missiles, like that. So underwater and surface in the air all covers the combat systems operation. And the combat system composed of the navigation systems, weapon system, and tactical communications and sensors and the combat management systems. All the sensors and the weapons are integrated well. Sensor location and coverage. There are many sensors in the first long range volume search radar and the multifunction radar and electric opticals and the IRST and surface search radar. This overlap the many parts because the one is failed, another is covered. Another combat system should be covered. So any direction and the range superposed their missions to protect and attack enemies from the enemies. And the weapon coverage and allocation. The long range is theater defense and the zone defense, ownership defense, step by step. From long range to close range, they allocate many sensors and weapons. Next is the warship acquisition process. Probably Korea weapon system acquisition flows are there. Requirement of military agency, requirement request, and joint in the Navy, requirement to set up and request joint chiefs of staff, and the requirement are decided in the joint steps. For that, policy, theater, threat, and the mission assessment, all the many things are considered for requirement to consolidation. And after that, DAPA, Defense Administration of the Procurement Agency, advanced research and establishment basic defense acquisition, promotion plan, and R&D and purchase. For developing the R&D and for purchase from the foreign countries, we purchase like that RFP and the proposal registration and the target equipment selection, like these procedures. Next is the warship acquisition process. In the United States, warship acquisition process this like that. The R&D exploratory design and the feasibility studies and the preliminary and the contract and the detailed design like that. About this full design phase, about 10 years are needed. In my country, feasibility study, concept, and the basic design, detailed design, construction like that, and the feasibility about 1 year, and the concept design or the 1 year, design, basic design, and the two years, detailed design, and the 3 or 5 years like that. So concept design, feasibility study lead the Navy, and the concept design is Navy and DARPA, and basic design shipyard. And the construction also shipyard. So all the design phase closely connected and interfaced. So many countries are similar to Warship acquisition process, but in these days, technologies changed very quickly, and warfare concept is different, changed. So this design acquisition process very squeezed, and about 10 years to 6 or 5 years, they changed that. And the warship design is the technology is very fast changed, developed, so complexity is changed quickly. As you see, the x-axis is the time, and the y-axis is some complexity. Increase the more complexity and increasing the risk and time. As you see, the emerging technology and joint interoperability and shift-wide and open architecture systems like that, and from the past to in these days, they changed many things like that. So to the right-hand side, more risk and higher cost needed. And I'd like to introduce some of the stakeholders of the warship procurement. Joint chief of staffs, and they do the requirement, the capability, and interoperability they set up. And Navy, requirement of capability and concept design, and the time level requirement and test evaluation. And ADD, R&D support, and DARPA, planning, execution, project managing. And shipyard, design, build, and quality control. And for shipyard, the complex system design, manufacture, and supply, and many equipment makers supply, and DQ, AQ, and quality assurance help the shipyard, and many university and research centers supply the help the shipyard. So all the stakeholders very closely cooperated, then we can get the optimum warships. Now let's discuss about the warship design concept. Up to now, any other questions for that? Okay, if you don't have any questions, I will lecture going fast. Warship owner's requirements are different from between the warship and the commercial ships. So the commercial ships requirement, as you know, the ship type, deadweight, capacity, cargo, service speed, dimension, maximum draft, cruising range, daily fuel, like that, delivery day, price, special requirement, some special ships. But Navy's requirement are some very different, because the combat mission is they carried out. So operational capability review, mission area, system necessity, and system mission operation concept. And threat, what is the threat factor? And threat environment. And mission scenario. And the mission, unit mission, and combat environment, and battle scenario. And required capability. Operation performance, mission scenario, core performance, interoperability, human and man interface, logistic support, like that. And acquisition schedule and support system, and ship design requirement. This is some needed for ship designer. All these operation capability component emerged in the ship design requirement. Mission and system requirement, mission, interoperability, right weight, maximum speed, endurance. Endurance means in the cruising range in the commercial ships, and operation environments, combat system, F1 sensor, IRS, etc. And survivability. Signature, about the survivability, I'll explain afterwards. Signature, shock factor, MB, noise and vibration, EMX. All the requirements, the Navy requirements, converged some the concept to details. First, what is the force requirement? What is the total ship requirement? And what is the combat system, the major system requirement? And what is the subsystems requirement? The requirements are squeezed and optimized the step by step. Detailed requirement is set up by some long time research, long time and design. They can reach some detailed requirement. And the warship concept design, we can see the right-hand side the time and left the y-axis is the cost and the performance. Early stage cost, early stage and the preliminary contract design cost is very small, but the performance is very high, flexibility is very high. So from the beginning of to the finish of the shipbuilding, cost is incurred very increasingly quick, highly, and the performance is some converges some level of the requirement. This is the design, the commercial ship design process, the basic design in the product engineering, design completion level. Maybe some commercial ship design process is some different according to the shipyard and the countries. This is some American, in United States, commercial ship design process. Concept, preliminary, contract, functional, and transition, and the work inside. Comparing the warship design process, that the concept design, engineering design, and production design, and functional analysis, and analysis of the alternatives, like that. Details are in the many design completion, mission, and levels. So you can see the many details in the pictures. Before the design, designer have to set up the design philosophies for what types of warships, what is for mission, like that. We can set up the design philosophy. Example, what is the priority for combat capability, survivability, manning reduction, operability, acquisition cost, habitability, fleet support operation, maintenance, like that. But this, the sequence of that can be changed according to the ship type and the mission. For example, in these days, human cost is very high, so manning reduction is very, very important. In the United States, in my country also, general trend is the minimize the crew and the combat people, so manning reduction is very important. For example, the general arrangement, topside arrangement procedure, the topside arrangement is very, very complicated and important. And because the many sensors and weapons are arranged to optimize and maximize their functions. Topside arrangement considerations factors are there. Combat performance, what sensors or weapons are arranged optimally, and detection range, the sensors detection range. Sensors are needed the detection range, maximize that. For that, some the black zone should be prohibited, so maximize the bearing, the detection bearing and range, and the detection firing coverage, and what many weapons assure the coverage and ranges, and some stealth RCS, IR, URN. For example, the effect of stack plumes. For example, this is the stack of the gas turbine. This plume can be affected some the sensors and the weapons. So the optimum arrangement is needed, and many sensor, electric sensors and equipment, electromagnetic capability and electromagnetic interface, and survivability, installation and maintenance, etc. All considerations are considers to topside arrangement. And hull arrangement procedure also requirements and constraints, start and deck and subdivision and tank, engine and auxiliary rooms, and many outfittings and elevations. For that, many considerations are needed. Structural arrangement, blah, 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 installation and management. So hull arrangement also very complicated. Hull form design. Hull form design is very similar to the commercial ship, but the different considerations for warfare. For example, for warfare, quick speed and propulsion performance and seakeeping. For example, in the warships, if warships are inclined to 90 degrees, the warship can restore in the and intact and damage stability. Damage stability means if it hit by the enemies, the missiles or guns, damaged conditions, they have to assure the stability. The arrangement stairs like that. As you can see, this triangle, this x-axis buoyancy and the powered lift and dynamic lift. So if the speed is from slow to high speed, like the first buoyancy ship and the hydrodynamic lift, hydrofoils and like that, and more quickly, for example, the air cushion vehicles and surface effects ships is about 40 and 50 knots. This is about 30 knots, about 20 knots, like that. Now, I'd like to introduce some ship survivability. Survivability is very important in the warships. Survivability is the capability of some naval ships to avoid and or withstand man-made hostile environment while performing its missions. We classify the three components: susceptibility, vulnerability, and recoverability. So susceptibility means some capability to avoid the detection. For example, for our ships, how to avoid the detection from the enemy. For that, operation advantage, susceptibility is for susceptibility, we made some operating advantages and the signature reduction, radar cross section, and the infrared cross signature and underwater noise, radiating noise. So enemy cannot find our ship due to the low signature. Reliable self-defense system, close-in weapon systems. If the missile is hit closely coming, and our ship CIWS firing and engage and hit the missiles. And if we, to avoid the jamming and the deception, decoy tactics, so shadow zone should be cleared to susceptibility. And next is the vulnerability, is the capability to withstand to a hit. Once enemy attacks our ship, how to withstand the hit? For that, operation advantages, general design. In the ship general arrangement, there we can divide by some the independent design zone to decrease of the, to enhance the vulnerability, and optimum range of system, optimal range of systems to maximize vulnerability. By using the optimum arrangement, we can get the more vulnerability. For example, the similar systems don't install the neighborhood. So if one hit is one hit in ship, so another zone should be survived. And next is for that protection against the hostile weapons, air explosion, underwater explosion, nuclear and bio and chemical protection. They have the design protection for enhanced vulnerability. And recoverability. Once we are hit, the capability to reconfigure and restore the damaged system after hit. For example, damage control, fire, flooding, monitoring, and replace the maintenance and the crew evacuation, escape, and many modular mission systems. For the warship designer, we have set up some total ship survivability. As you see these pictures, TSS represents survivability, design philosophy and concept, support the ship design process and survivability, R&D and live fire testing, evaluation, and the life cycle support. As you see the pictures, x-axis is the time, y-axis is the platform capability. If it is no hit, 100% function. But once hit, the capability, the performance is decreased. And the secondary damage effect, for example, in the one hit the ship, inside the ship, the explosion is the secondary damage and the decreased war. For example, the fire and flooding like that. And for recovery systems, we recover the full recoverability. So the performance is decreased, and the next is increase the capability. For susception is the signature reduction, and if one hit, the recoverability is needed for that. Any more questions up to now? Maybe many students maybe maybe sleeping. If we don't have any questions, I'll continue my lecture. In these days, many environmental world conditions changed and the technology changed. Many warship design the trend is very different. So in these days, I'd like to introduce some of the warship design trends. First, let's reduce the signature. As you consider the survivability point of view, we have to reduce the signature. For that, radar cross-section. Radar cross-section means if we radiate radio signals and the response come again, then we can catch the radar systems, the target, the characteristics, range, and bearing. So if we incline some angles of the ship structure, if radio signal is coming and not come back, but they scatter to another direction, so enemies cannot catch my signatures. For normally the radio cross sections are all like that, but inclined conditions, their signature is very, very small. So this type of the warships are extremely decrease radar cross sections. Next is reduce the signature of the infrared. Infrared categories are classified medium infrared and far infrared. Medium infrared, the target of the missiles, and the far infrared is the target of the classification of the ship. What type of ship? What is number of ships? So normally to reduce the MIR signature, normally in the stack, they cool down the flumes in the stacks. So for example, like that, IR, which called infrared suppression systems in the stack. And to reduce the FIR, we cooling the surface of the ship structure and decrease the far infrared. So this is the unsuppressed ship and the medium suppressed ship, and the advanced ILSS suppressed systems. We cannot find our ship easily. And next is the underwater radiated noise. This is some of the propulsion system and the configuration, diesel engines and generator and main drive motors and the reduction gears and propellers. This diesel and the cylinder firing, the vibration source are cylinder firing injection systems, and the generator is the various pumps and the fans, etc. And the main drive motor is the slot pole noise, and the reduction is the gear whine, and propeller shaft and propeller blade. In the warships, most vibration source is the diesel engine and reduction gear. And high frequency is the propeller noise. So for reduce the signature, we can special design for installation. For example, this is the vibration source. So observing the vibration, the blocking and vibration, the resilient mount, and this double resilient mount we introduce, and observing the air noise, observing the materials inside that, then the special design, the propellers is needed there. Next is the electric propulsion systems. In these days, many high energy weapons are needed to the ships. So in the past, the most propulsion system is needed for propulsion, but this time the high energy weapons needed so for power flexibility, for high power weapons and reduce underwater radio noise and improve survivability. For that, we normally hybrid propulsion system and the full electric system. As you can see that the hybrid propulsion systems are propellant engines and the generator. For high speed, they connect the propellant engine gearbox and the propellers, shaft and propellers. But in the low speed, for anti-submarine warfare, the generator and directly connect to the motor and the propellers, so they can reduce the underwater noise. And the fully electric system is no for high speed or low speed. Also, they made the electric energy from the generator and directly the propulsion motors to reduce the vibration and the noise. And the shock fruit underwater explosion. There are many mines and torpedoes in the water, so we have the shock-proof design, near-field explosion and far-field explosion. Near-field explosion is the explosion from the very near-field explosion. So as you can see, the void detonation, and second is bubble effect, and due to the bubble effect divided by the 2. For most of this is the very severe condition. So designers not consider this one. Most of the ship designer far-field explosion condition. Interesting thing is the for ship design, okay, let's jump for more things. And integrated mast systems. This is the conventional mast systems and change like the enclosed mast systems for minimizing RCS, right? Maximize combat system, improve like that. And the modular design and multi-missions like that. So modular open architecture, different mission model, and modular open architecture for take advantage of the several missions. So according to the mission, they can carry some modules for mine missions, or mine modules they carry. The amphibious modules, amphibious module carries like that. And the combat system has augmented AR reality and the open systems and the artificial intelligence aids like that. And unmanned systems, unmanned surface vehicles, underwater vehicles, UUV, and unmanned air vehicles. I think in the United States, 50% of the aircraft carrier is the unmanned UAV. And so step by step, in the future, most of the mission can be carried out by the unmanned systems. And tumbler wave piercing hull. As you can see, there's some different because the tumbler is some zoom out about 10,000 tons Jumal class destroyer. This is the 600 feet actual length, but the reduced RCS, the enemy can get the Jumal signature about the 50 radar cross section. So very very high inclined surface. For that, no flares and narrow of the ship hull with great distance from the front. So this is the maximum I see here. And for that, reduce the wave making resistance for high speed and get better sea keeping and the stealth for RCS signals and stability in the, but stability is not good for rough ship. And Jumal class is a technology advanced surface ship. This time, most enhanced, most advanced destroyer in the world is the Jumal class. Infrared mock-up and many new technologies are applied there. And next 2050, UK set up the future combat ship concept like that. They are very different from the conventional ships. Stealth design and the way piercing the sea frame and the large flight deck, ultra strong acrylic hull, and extendable deck and hangars, and the main boom pulse and propulsion systems is a fusion reactor for about 50 knots speed, and many automated AI systems are introduced. And the hovering in this war environment, many satellites constellation is around the cosmetic field. So all the systems, all the ships are contact from the artificial satellite. So to avoid that, the ship should be under the sea level. So we inside the water, in the whole ship body and the hovering tethered quadcopter is by using the tethered line outside of the sea level, then they can contact and some attack to against some drones, airplane, and many missiles for high level, high energy laser beams like that. So hovering tethered helicopters and energy weapons, defensive hypersonic missiles, supercaptive propellers are introduced. This is very interesting. And the 3D holographic command table like that is very, very future design trends. I'd like to introduce my Korea, the turtle warship. 1590s in Joseon Dynasty. Korean peoples know already, but I'd introduce some the French or another country student. Admiral Lee Sun-shin and Da Dae-yong is 16th century. They developed the turtle warship. Installed the long range 14 guns and the starboard port like that. This is the first time in the world. And cover the Iron Dome for visual stealth to prevent climbing the enemy on ship and prevent the green wall, so cover the Iron Dome. and short range, the better maneuverability, the shallow water, the short draft, and for strong hull structure, they made by the pine tree wood. Okay, last thing is the United States ONL Office of Naval Research. They suggest 9 major science and technology. This is the for future naval warfare. The United States want to develop the new technology. These areas, some assure access to maritime battlefield space, autonomy and unmanned systems, electromagnetic maneuver warfare, and extraordinary and irregular warfare, information domain, cyber, and platform design and survivability, and powered energy, and power projection and integrity defense, warfighter performance. Many of things are related to that already I explained before. Especially these are very future battleship technologies are needed for development. Any other questions up to now? Student, are you sleeping? French student, may I know your names? Hello? 다 들어가 버렸는데. Okay, I'll finish my lectures. I think the warship design and the R&D will be the good job for your future. And I suggest the best ship in your life will be Friendship in your KAIST. About 1 hour, I briefly and quickly cover some warship design and the characteristics. I hope the KAIST student in the lecture on the warship design should be helpful to your future your job for that. Thank you very much. Any questions?
No questions.
No questions? Cannot understand? Okay, let's finish our lecture. Thank you. Bye.
All right, we can finish the class now. See you next Tuesday for the project presentation. Bye now.
안 들린 것 같은데? 응? 안 들린 것 같은데?
마이크들을 다 꺼놓고.
감사합니다.
네.